All right, so in this video we're going to do some logarithm review. So we'll start with the definition of the logarithm. We'll look at two logarithms. So we'll first look at the natural log of x. So the natural log of x, it's defined to output the power of e that x is. Okay, so if we have an input of e, if x is e, the power of e that e is 1. So this function will output 1. If we put in e squared into this function, it'll output 2. If you put in e cubed, it'll output 3. Let's put in some other values. Let's put in 1 and 1 over e. So if we put in 1 is e to the 0. 1 is e to the 0. So this function will output 0. And 1 over e is e to the negative 1. So this function will output negative 1. All right, so let's graph the natural log function. So e is approximately 2.7. So if we have an input of 2.7, an x of 2.7, this function is going to output 1. If we have an input of 1, it's going to output 0. And if we have an input of 1 over e, which is around a third, we're going to output negative 1. Okay, so our function looks like this. This is the natural log function. All right, now let's look at another log function. Let's look at the log base 10 of x. Okay, so this function outputs the power of 10 that x is. So you give this function x, and it asks what power of 10 is x, and then it outputs that power. All right, so let's put in some x values into this function, into this log base 10 function. So we'll put in 1/10, 1, 10, and 100. If we put in 1/10, the power of 10 that 1/10 is negative 1. If we put in 1, the power of 10 that 1 is 0. If we put in 10, the power of 10 that 10 is 1. And if we put in 100, the power of 10 that 100 is 2. Okay, so now we can sketch the graph of log base 10. And this is not to scale. Okay, so if we put in 1/10, we get negative 1. If we put in 1, we get 0. If we put in 10, we get 1. If we put in 100, we get 2. So this log base 10 function looks like this. Again, the x-axis is not quite to scale. All right, so now let's talk about some properties of logarithms, or logarithm rules. So the first rule is the natural log of a times b is the natural log of a plus the natural log of b. The second rule is the natural log of a over b is the natural log of a minus the natural log of b. And the third rule is the natural log of a to the power k is the same as k times the natural log of a. And these rules work with any logs. All right, so those are the logarithm rules. And then we have an important formula called the change of base formula. And it looks like this. The log base a of x is the natural log of x over the natural log of a. And log base a is asking the question, what power of a is x? And then it outputs that power. So this change of base formula gives us a way of computing logarithms of any base using the natural log. The change of base formula can also be written with log base 10, like so. All right, so let's do a couple examples involving these formulas. So the first example, I'm going to ask us to expand the expression so that there are no exponents. And here's the expression, the natural log of x squared over y cubed. Okay, so the first thing we'll note is that we have a quotient here, natural log of x squared over y cubed. So we can rewrite that as the natural log of x squared minus the natural log of y cubed using our second rule from above, this rule right up here. Okay, and then once we have this, we can note that we have the natural log of x squared and the natural log of y cubed. Those can be written as 2 times the natural log of x and 3 times the natural log of y using this third rule. This rule says we can bring the power down in front as a coefficient of the natural log. Okay, and now we have an expression with no exponents, and so we're done with this problem. Let's do another example. So in this example, we're going to combine the expression into a single log. And here's the expression, 4 natural log of a plus 3 natural log of b minus the natural log of c. Okay, and so we're really reversing what we did in the last problem. We're taking these coefficients and we're going to write them as powers using the third rule. And then we're going to combine these. We're going to combine these using the first and second rules. So the first rule says if you have a sum of logs, that can be written as a log of the product of the insides. And then if you have a difference of logs, you can write this as the log of the first inside over the second inside. And this is an expression with just a single log, and so we're done. All right, I hope you found this review of logarithms useful.